Welcome back, Marauders. This video 16.7 is about weak bases. Hopefully you've already looked at the video on weak acids and you've learned how to calculate the pH of a weak acid solution when given Ka. This one's going to be about bases, and you'll find that it's pretty similar. So if you know how to do the acids, you shouldn't have much trouble with the bases. So first of all, this is just a generic equation for a base. And so what do bases do? Bases accept protons. So a proton can be lost by water and come over here to the base. So B is just any generic base. And so when it gains a hydrogen, it becomes Hb plus. And then the water, when it loses the proton, it becomes OH minus. So this is your base. And then over on this side, you have a conjugate acid, and you have hydroxide, which is your conjugate base. All right, so since this is an equilibrium for a weak base, only some of it is going to become product. A lot of it's going to stay as reactants. We want to be able to figure out how much stays on each side. So we can write an equilibrium expression with your products on top. So Hb plus, the conjugate acid, will be on top, along with hydroxide. And then on the bottom, you're going to have your base. So that'd be your equilibrium expression. And then just like with the acids, when Ka was small, it means it was a very weak acid. And then as Ka got bigger, it became stronger and stronger. So when Kb is really, really small, you have very little of these things being produced, so very little hydroxide. And then as Kb gets bigger for slightly stronger bases, then you get a little bit higher concentrations of these products. You get a little bit more hydroxide at equilibrium. So let's try it out on a problem like this where we need to find the pH of a weak base. So pyridine is a weak base. Calculate the pH of a 4 molar pyridine solution. Kb is 1.7 times 10 to the negative 9. Okay, so for our base, if we know the formula, we can write it out. If we don't need it. We can just write B for any generic base. And so that reacts with water to make, so it's going to take a hydrogen away from the water. So it makes Hb plus, which is going to be your conjugate acid. And then the water, after it loses the proton, is going to be hydroxide. All right, it's an equilibrium problem, so we'll make an ice table. Water is a liquid, so its concentration never changes, so we'll leave that out of our ice table. The numbers that we know starting out, we know that it's a 4.0 molar solution. So the initial concentration of your base is 4.0 molar. And then these are starting at 0. We can write out our equilibrium expression. So Kb is equal to, we're going to put our products on top. So Hb plus and OH minus will be on top because those are your products. And on the bottom, your reactant will be the base. So in this problem, they gave us Kb. It is 1.7 times 10 to the negative 9. And then we don't have anything else, so we need to figure out what these changes are. These can only increase, so they're going to go up by x. So this will be x. This is going to change the same amount, so up by x, x. This will decrease by x. This will come out to be 4 minus x. Okay. We can use the same kind of assumption that we use when we're dealing with the weak acids. We know that x is going to be pretty small because Kb is really, really small, meaning not very much of it is going to go here to the product side. So x is going to be really, really small. When you do 4 minus a really small number, it's still going to be pretty close to 4. So we'll make that assumption to make this a little bit easier of a calculation. 4x times x on top, or x squared. So we have this equation, and now we can solve for x. It should be pretty easy. And we find that x is equal to 8.24 times 10 to the negative 5. Okay. Important on these questions when you're dealing with a base, remember what does x mean? Well, x means the concentration of hydroxide. So now we're going to use that hydroxide concentration to find the pH is what we're trying to find. Easiest way to do that is probably to find the pOH. So remember, pOH is negative log of the hydroxide concentration. So negative log of 8.24 times 10 to the negative 5. And we find that pOH is equal to 4.08. Okay, pOH is not the same as pH, but there's a pretty easy equation that relates the two. So pH plus pOH is equal to 14. And so pH is equal to, pH plus 4.08 is equal to 14. And so pH is equal to 9.92. Okay, so that is how to find the pH of a weak base solution when you're given Kb. Set up the ice table, solve for the concentration of hydroxide, and then once you have the concentration of hydroxide, you can find pOH, use pOH to find pH.